Hi there, this is exercise 1C.2. If you remember, there was actually two previous ones to this. There was a 1C.1 and a 1C.1 continued because it overran. But essentially we went through the 4 standard summations results last time, of which I've got 2 on the screen for you now. So this one is the one for the quadratics, and this one is the one for the cubics. And if you remember, if you know you want to add up all the numbers from 1 to, say, 26, or all the square numbers from 1 to 26, you could effectively substitute 26 into this equation and give you the answer. But there are some other formulae as well that we knew we needed, and these 2 are not actually given to us in the formula, but whereas the other, the 3 and 4 are. So just be aware that there are 2 that we know are going to be told, and 2 that we know we'll have to learn. So let's just have a look at this. It says find the sum. All right, we saw a couple last time, well, one last time, which started at 0. And if you remember, what we did was we just substituted 0 in, because the whole point is our formulae start from 1, and ours here doesn't. It starts at 0. It's a bit of a rubbish one, really. Because it says 2r cubed plus r, and if I substitute 2 times the 0 cubed plus 0, well, my extra term turns out to be worth nothing. So I'm not quite sure why the question's asked us to do that, but it's the same idea. So really this is just the sum from r equals 1 to n of 2r cubed plus r. And what we obviously do with this is we split it into 2 lots of the r cubed formulae, r equals 1 to n, plus just the r from r equals 1 to n. And I don't really like writing that all the time, the r equals 1 to n bit. Anyway, it's 2 lots of the r cubed formula was the 1/4 times the n squared, n plus 1 squared. And the other formula for the r's was 1/2 of n plus 1. So you either learn them or look them up. And the great thing about this is 2 times 1/4 is the same as that over there. So I get 1/2 comes out. Actually, I get an n that comes out of both of them, and I also get an n plus 1 that comes out of both of them. So there's a lot to come out as a common factor. And once you've taken out your common factor, I tend to write a bracket. Well, that's all taken care of. I need an n, and I need an n plus 1 for this first one. And this second one is actually exactly the same as I got. So obviously you times this by 1 to get that again. So what have I got? I've got 1/2 of n plus 1. What goes into my bracket? And in my bracket I get an n squared plus an n plus a 1. I'm not convinced looking at that. It factorizes. Yes, that's right. So didn't factorize, so I just left it as a quadratic. What's this next one do? Well, first of all, note it goes up to n. That's all important. It starts at 1. So it's just a fairly standard one. I'm going to split this. Oh, well, I nearly went wrong. Look, it's actually a squared. So one thing I should really do, I suppose, is multiply out that 2r minus 1, which obviously gives me 4r squared minus 4r plus 1. Again, all of these should really say r equals 1 to n. Now I'm going to split this into 4 sigma r squareds minus 4 sigma r's plus a sigma 1. And if I do this, I get 4 lots of the r squareds were a 1/6 times by n plus 1 to n plus 1 for memory, minus 4 lots of 1/2 of n plus 1 for the sigma r's, plus the total of all the ones. If you remember, they just add up to n. So what's this gives me? It gives me 2/3, and this gives me 2. I'm tempted just to write it one last time just to make it a bit more obvious, and then I'll take out a common factor. So that gives me 2 lots of n plus 1 plus an n. So I'm going to take out the lowest common denominator, so I'm going to take out 1/3. There's an n in all of it. Unfortunately, this has only got the n, so that's actually where I stop. So what's that gives me? It gives me 2 lots of these double brackets. So I'll multiply those out. 2n squared plus an n plus a 2n squared plus 3n plus 1. Now, what do I times a third by to get 2? I reckon 6. 6 thirds are 2, yes, that's right. So it's 6n plus 1. And what do I times a third n by to get n? I reckon plus 3. So that gives me a third n. I get 4n squared plus 6n plus 2 minus 6n, don't forget, minus 6 plus 3. That's a third n. What have I got? Well, there you go. I've got 2 minus 6, which is minus 4 plus 3. Alright, so it's 4n squared minus 1, I think. That sounds reasonable. And that gives me then a third of n. Obviously, this is the difference of 2 squares, so it's 2n plus 1, 2n minus 1. Let's just check to see if that's right. Where's the answer? Yes, that's right. Third of 2. They've written the other way around, but essentially that's right. Okay, good. Next question. This is June 2011. You're hopefully getting used to this, expressing in a fully factorised form. But notice this goes up to 2n. So my first thoughts are, well, I just need to be aware, so please don't draw that line, because if I go from 0 up to 2n, which is what I need to do, somewhere along the middle is n, and the point being, oh, actually no, this is just going from 1 to 2n. Alright, I thought it was doing something else, it's not. So if I'm going from 1 to 2n, that's relatively straightforward. I'm going to do 3 lots of r squared from r equals 1 to 2n minus a half of some 1s. Notice a half I just treat as a half of some 1s. So from 1 equals 2n again. Now remember the formula for r squared was, which should write sigma r squared, normally is a sixth. N plus 1, 2n plus 1. Now what I have to do therefore is because I want to go up to 2n, I have to change this to 2n's. So I reckon that's going to be 3 lots of a sixth. And rather than n, I'm going to write 2n. Rather than n plus 1, I shall write 2n plus 1. And rather than 2n, now that's 2 lots of n plus 1, which is 2n plus 2. Just make sure we're doing that. No, that's me talking rubbish. It's 2 lots of 2n plus 1. So that's 4n plus 1. Minus a half of, and normally, if you add up all the 1s, you get n. But if I go up to 2n, I'll get 2n. So it's half of 2n. You can see what they've done here. That cancels. 3 times 2 is 6. Divided by 6, so that cancels as well. So I'm left with just an n going in to both of them. And on this one I get 2n plus 1. 4n plus 1. And this one's really just an n, but I've got an n, I times the n by 1 to get that, so that works. So that's n lots of, what have I got? That's an 8 honest. 8n squared plus 6n plus 1. Don't forget the minus 1, which makes it nice and factorisable. Gives me 8n squared plus 6n. And I reckon 2n go into both of these things, so that gives me 2n times where the n is squared, and in brackets I get 4n plus 3. I reckon that should be it. 2n squared, 4n plus 3, perfect. So next question, what have we got? It goes up to n. This looks like quite a gentle one. There's just 3 of them, I suppose, that's the difference. So it's 4 lots of sigma r cubed minus 3 lots of sigma r squared plus a sigma r, and all of them go up to n, so this is quite a straightforward one. We don't have any special tricks. 4 times a quarter of n squared, n plus 1 squared. That's the first bit. Minus 3 times a sixth of n plus 1, 2n plus 1. And the last one is a half n plus 1. Okay, back over here, that cancels. this becomes a half, and that's a half as well, so I can take out half as a common factor. I've got an n that goes into each of them, and I think an n plus 1 that goes into each of them. So what goes, that goes out, we've got one of each extra. Now, oh actually I made a mistake there as well. This is a whole one, I've taken out a half. I think I'm going to squeeze a 2 there, because 2 times the half will give me the whole one. That's better. This is a half. So I've got an n plus 1 and a half. So I've only got 2n plus 1 there. And this one is exactly what I've got, so that's a plus a 1. So a half of n plus 1, multiply out this bracket. What have I got? I've got 2n squared plus 2n minus 2n minus that 1 plus a 1. Lots cancelling there, I think. I've got half n plus 1. That goes, that goes, that goes, that goes, times by 2n squared. So 2 times a half is a whole one. N squared times the n is n cubed. I think it's very gentle looking answer like that. It took a bit of work to get there. Let's see. N cubed n plus 1. I think from memory this is the last one. So the first thing I notice here, this is one of those ones which I thought the other one was, but it turned out not to be. It goes from r equals n to 2n. Now, that's even, it's not an obvious one at all, this. Now, if I go from 1 up to 2n, now somewhere in between is an n, but I want all of these. I want from n to 2n. And the one before the n is n minus 1. So that means I've got to take away this lot. We're doing something similar last time. So if this summation of r cubes, what I've got to do is the sum from r equals 1 to 2n, all the way up to the top of the r cubes, and then I've got to subtract from r equals 1 to n minus 1 of the r cubes. And you remember I said you've got to start on 1 really, because they're the ones we've got formulas for. So up to 2n, remember the formula for the r cubes is a quarter n squared n plus 1 squared. It's actually a nicer formula than the squared ones. So it's a quarter. Now it goes up to 2n, so I've got to do 2n squared. And normally it's n plus 1, but for me it's going to be 2n plus 1 squared minus a quarter. And I've got to do, well, I've got to sub n minus 1 into there, so it's n minus 1 squared. And then I add 1 to it, which fortunately just gives me n squared. And I say fortunately because I've got n squared in both. So I can take, I know I'm going to end up taking, I'm going to reckon I'm going to take out a quarter n squared as a common factor, because nothing else goes. Now, as it happens, that's 4 divided by that. This is a whole n squared when I do it. So I've got 4 lots of this. The quarter matches, the n squared matches. I've got minus the n minus 1 squared. So I've got to be careful with multiplying that out. What is that? It's 4 lots of 4n squared plus 4n plus 1 minus an n squared minus 2n plus 1. Conscious of time here, so it's a quarter n squared. This gives me 16n squared plus 16n plus 4 minus an n squared plus a 2n minus a 1 equals a quarter of n squared. And what I've got, 15n squared, that's those two gone, plus 18n plus 3. And now I've noticed 3 comes out as a common factor, so I reckon 3/4 of n squared n plus 1, 5n plus 1 is probably very good. Now I haven't got time to do the last bit, we're out of time. It was just a hence find this. Oh, this is just a combination of that. Notice it goes, that's got an r cubed in it. So your job is to finish off. Ooh, run out of time.